Hi everyone, welcome to another episode of the Data Standard Audio Experience. I'm here today with Kevin Wu, the Chief Data Scientist at Consumer Edge. And today we're going to be speaking more about NLP and tracking different trends in the field today. So welcome to the show, Kevin. I'm so excited to have you today.
Likewise, great to be here, Catherine.
Yeah, and could you just go ahead and tell the audience more about your background and introduce yourself? I know that you had came from a more non-traditional path of a different type of background, so we'd love to hear more about that.
Yeah, that'd be great. So currently I'm at the Chief Data Scientist here at Consumer Edge. We're an alternative data vendor. Basically, that means we sell data to hedge funds and mutual funds and big institutional investors. But as you said, I kind of took a unusual path here. I did study engineering and economics in college, but then went on to a career investing in the developing world, what they call the emerging markets, for almost 10 years. And it was not quantitative investing, it was very much fundamental. I traveled the world and looked at a lot of mining sites and oil rigs. While that was fascinating and incredibly thrilling in my 20s, after about 10 years of doing that, there was a break in my career and I really sort of reevaluated what I wanted to do with my life. And I, at the time had a deep interest in what was an emerging field called data science. The term basically was very new at the time. But I wanted to make a change to do that because that's something that at a very low level made me happy. Making decisions with data was something that was very, very important to me. And so I spent a lot of time reskilling while taking some time off there. And I relied heavily on open online courses that were becoming prevalent at the time. I'm a big fan of Andrew Ng and what he does at deeplearning.ai. I've taken every course that he's offered and other courses on Coursera as well. And I was fortunate enough to be able to get a job at Capital One doing data analysis work. I did things like Kaggle competitions and did fairly well in some, and I think that kind of bolstered my resume. But yeah, they were able to hire me without really much experience. And one thing I want to emphasize is, like, while I was there, at a big company, they provide a lot of resources for people to learn more about those skills and really to get closer to like best practices in a lot of areas. And I took full advantage of that. I made a point of basically doing every single tutorial that related to data science and programming at the company. And I think I learned a lot there. And that eventually led me to my current role, which was a perfect mix of the two skills that I'd done in my career.
Yeah, and it's clear that been very motivated to get into kind of the data analysis, data science kind of field, being able to learn all this stuff on the side, and you're definitely very driven to kind of learn this stuff on the side as well, and that's great to hear. And with natural language processing throughout the years, it's really grown as the years kind of continue and technology really advances as the years go by. And how are you using NLP at a high level to track different trends that are going on right now?
Yeah, that's a great question, and it's really fundamental what we do here at Consumer Edge. One of the things that I think the economy has moved to a place where many economic transactions at this point are digital in some form, and they produce a lot of metadata. And if you can get your hands on this metadata, using natural language processing becomes very important to relating that metadata to real world events. So, can you identify this transaction and say it occurred at some company's brand or at some particular store location, or just classifying it as any particular industry? And that's kind of really where the NLP comes into play. The techniques vary greatly, but there's very classic natural language processing techniques like EDIT or Levenstein distance, or like the SoundX algorithm, or like n-grams, all the way to more modern methods like word embeddings and vector space representations. And if you do this well, what's kind of cool is then you can aggregate this over time, or geographies or industries and demographic variables, whatever you can get your hands on, with this metadata. And it gives you very timely and very granular reads on, economic activity at a particular company or region, or even on the economy broadly. I think we're very proud at Consumer Edge that our data is now used by the Chicago Federal Reserve in an index that they publish, I believe, weekly to track retail spend in the United States. And that just sort of shows you the power of it, that it's helping set monetary policy.
Yeah, absolutely. And NLP has been able to really improve just the world in general in a lot of different aspects. But with a lot of these models that people have to build with just using natural language processing in general, there's going to be a lot of challenges that people are facing. What are some challenges that you faced when working with NLP?
Yeah, that's a great question, and I think it is maybe lost on a lot of like early people earlier in the field that are less adept at this. But I would say scaling is the biggest problem that we face. I like to think of a canonical problem, which is like sort of entity resolution, where you're trying to find two things that are similar or are duplicated perhaps in some list. And so you can imagine that if you had n queries of things that you don't know are duplicates or not, and then some index of length m of things that is sort of your source of truth, to figure out whether you have duplicates or not, or that they are, going back to the NLP to tracking trends paradigm, is this piece of metadata associated with this real world thing? You would have to do n by m comparison, or on the order of n by m comparisons. And that's generally infeasible for a reasonable size data set, and certainly for what we do, which is handle tens of billions of transactions and trying to look at hundreds of thousands of real world sort of entities. So some of the ways that you can try to deal with this is don't compare them all, and I guess some methods are blocking or predicate blocking, which is that you can probably find some simple function that produces some feature that's shared by things that are a match. And then the percentage of those that would share that feature are going to be much lower than obviously every single comparison. And the idea is that you can use that to reduce the number of comparisons that you have to make, with a complicated function. This draws on concepts like inverted indices or locality sensitive hashing. But there's a lot of work that's being done on this in terms of approximate nearest neighbor search. And it's an area that we find fascinating to try to tackle this challenge, and we spend a lot of time on that.
Yeah, absolutely. And I know that you had mentioned to me that there's a lot of different trends that you have been able to track. And do you have a favorite trend that you've been able to track, and why?
Yeah, obviously COVID disrupted the economy a great deal. The measures to try to contain it, and then the relief to sort of help people in the economy as a result of that. And it was fascinating to see in our data that the government stimulus that was given to people in need really show up quite dramatically in our data. And so you could see some pretty interesting things where in general, people with debit cards tend to have less money than people with credit cards. And so we saw the spending for debit cards significantly outpaced spending growth for debit cards significantly outpaced the spending growth for credit cards during these periods immediately after relief was sent to people in need. And it sort of demonstrated to us the social value of that policy. But it was cool to see it in real time. Often you can't tell if something's going to work for a very long lag until GDP data is released quarterly with a very long lag, and then revised several times. And we were able to see this working in real time. And again, I think that's why institutions like the Federal Reserve were interested in getting their hands on this to evaluate the effectiveness of these policies.
Yeah, and that's interesting to see the comparison between that you had mentioned in the example between debit cards and credit cards. That's an interesting way to kind of see that analysis and just the backlash of everything that's been happening. In NLP, I know you work very closely with NLP. That's one of the main kind of aspects of data science that you work with. How do you see it changing in the coming years or advancing?
Yeah, I mean, obviously we've seen tremendous advances with models like GPT-3 or Google's T5 model. But I think that really just highlights the fact that at this point, what's available open source is incredibly powerful. And, so I think really where I see the focus going in the industry is the ability to productionize those types of models and really a focus on I think what people are calling machine learning operations or ML ops. And so can you reliably build a pipeline to clean your data, retrain your models, and then deploy them so that they can perform inference at scale and reliably? Make the processes much closer to the way software engineers do things than the way that traditionally data scientists who perhaps get a bad rap for their software engineering skills have traditionally done it. And I think we're starting to see some of the methods from like DevOps and around software engineering really come to the data science side, to the machine learning side. I think we sort of think that the days of like data scientists just being sent a CSV file and training a model and trying to get the best result, sort of out of sample results out of that are over. And we need to become more sort of holistic engineers who are capable of integrating this into a broader system with the special caveats necessary for machine learning in mind.
Yeah, definitely. Great, great perspective there. And I want to also ask you, do you have any final advice for those who are interested in going into a similar field or role as you that maybe don't have, a same kind of data focused background?
Yeah, absolutely. And I think that there is just a wealth of information out there and organizations that really support people looking to break into the field without traditional backgrounds. Places like the Data Standard definitely stand out. I'm located in New York City, and there's a data science meetups. There are venture capital firms that host talks with leaders in the industry who can really give people good perspective on this. But I think the most important thing is really when it comes down to it is these massive open online courses are now all of a sudden give people access to the best teaching available. No. I'm not trying to disparage my education an undergraduate, but likely, there's probably one person who is the best teacher of linear algebra, the best teacher of matrix calculus, and you get to watch the video of that person now online, often for a very low price, sometimes free. And if you have the will, you can take advantage of that and really learn quite a bit very, very quickly. And so I encourage people to look for, I'm a big fan of Andrew Ng's deeplearning.ai. And as I said, he's a co-founder of Coursera. So I found a lot of the material on Coursera to be excellent. But Stanford's library and MIT's library is available as well. I think if there's, it's really, people overuse this term, but it's really democratized the ability for people to learn these skills. And so I highly recommend, someone looking to get into the industry to take advantage of that.
Yeah, and I really like that piece of advice because it really shows that anything that you want to learn is already readily available on the internet. And a lot of it is also free. So it's really just a matter of how much time and motivation that you have and your willingness to kind of learn it on your own. But I think that's a great piece of advice that you have. Kevin, thank you so much for joining us today on the Data Standard podcast. Where can everyone find you online to connect with you?
I have a woefully small social media presence, but I am on LinkedIn. I think at Kevin Wu Public, and you can also find me on GitHub at KWU2U.
Yeah, perfect. And to our audience, for more information on the data standard, you can find us at www.datastandard.io, as well as on our LinkedIn and YouTube channel. And thank you so much, Kevin, for joining me. It was so great to speak with you and just learn more about just everything that you're working on with NLP and some of the advice and the journey that it took you to get to where you are today. So thank you so much.
Likewise. Thanks, Catherine.